Hey guys, welcome back. So today I brought home this Powermate generator. This one was free, and for good reason. It doesn't make power. Now, believe it or not, this is 10 years old. It looks brand new and only has 60 hours on the clock. The story behind this actually, a subscriber, Rob, who runs a repair shop, got this generator from a customer. The customer was complaining that it didn't make power. He ran the proper checks. He checked the ohms, which came back good. He cleaned the slip rings, inspected the brushes, and replaced the AVR. Still no power. So at that point, the customer said, keep it. And thankfully, Rob reached out to me to see if I could work some magic on it. So hopefully I can, but if you get a generator that's not making power, I would say don't count on it making power. More often than not, it doesn't, but sometimes it does. So let me get it set up a little bit better. We'll break out the multimeter and see if we can't figure out what's making this generator sick. Hopefully this multimeter shows up okay. I've got it set to ohms, and I want to check the main windings. That can be done actually through the outlets, the 120 or the 240. I guess the only issue with the 120 is that there's two 120 legs here, and you have to make sure you know which is leg 1 and leg 2. And in this case, I'm guessing leg 1 is here and leg 2 is here. But a better way to do this is to actually use the 240 volt outlet. The one with the prong here is the ground. Neutral is opposite, and then leg 1, leg 2. So we'll just put this in the neutral, and then the other lead into one of the legs. And generally, a generator like this should be less than 0.5 ohms. 0.3 is usually what I see, 0.3, 0.4. So this leg is around 0.2. And my multimeter actually has 0.1 internal resistance, so it's closer to 0.1 when you subtract that. So that's actually a very low number. That could be an issue. We'll check the other leg. And that one is a little bit high. So if you don't know what the reading should be, which I don't on this, you want to see that the readings are consistent. And in this case, they're not too consistent. Potentially there is some corrosion on these contacts. So let me check the 120s and see if we get a different number. Point 0.2 ohms. And guess we'll call that a 0.3. But there is a difference between the legs. I mean, say 0.3, 0.4, and this one was 0.2. So that is very suspect. There might be an issue with the stator. So let's get the cover off the stator and take a look. Okay, well, nothing's jumping out at me. This looks very clean in here. There's no dust, no corrosion. I don't see any broken ropes, so let's get this AVR out of the way so we can get a better look. Yeah, nothing's jumping out at me. The wire looks good, no broken ropes. no black marks. I'd say the only issue is that you can see the winding here isn't too clean. So it's a little bit sloppy. Also up there, wasn't wound very well. So yeah, maybe there is an issue with the stator, but let's keep going. I need to get these wires off. I want to isolate the main windings, and then we'll do some testing, more testing on the main windings as well as the windings supplying power to the AVR. And there's two sets of white wires on here. It shouldn't matter which way they go back, but I am going to mark the top white wire, which that's that one, and that's that one. So that way when I put it back together, it'll be 100% the way that it was. These two I'm going to leave connected for now. I'm not too concerned about them. Usually there is an extra winding when you have a fuel solenoid like there is on this generator, so most likely this is the one for that. And there's also a 12-volt charging circuit on the front panel, so most likely that's what the other one's for. But neither one of these is going to prevent the generator from powering up. It's most likely one of these windings or potentially a bad stator, but the stator looks fine, so I don't think it's a bad stator. Most likely it's a bad DPE winding. I'm going to check the DPE winding first. So that is this plug right here. The two blue wires are the DPE winding, and usually it comes in at 1.5 ohms. And we're at 1.6, and this meter has an internal resistance of 0.1, so we're at 1.5. DPE winding actually looks good. Let's check the sense winding. That usually comes in pretty similar to the stator, so I would say around 0.3, 0.4. And that's pretty good, 0.2. Then we'll check the main windings again from down here. So we'll do leg 1. Point 3, 0.4, that's pretty good. And leg 2. Yeah, so it's actually not too bad. It is a bit higher. I'd say it's like 0.1 ohms higher. And that's, I would say, acceptable. So things seem to be pretty good. I am going to actually check each winding to ground and each winding to each other to see if there's an insulation failure. So we'll start with the blue wires, the DPE winding. Then touch this to ground. And there's no connection. Now we'll do the sense winding. And that is not good. So that is the yellow and green wire. That is the sense winding. And yeah, that could be the issue. So the sense winding is usually off the main winding. So let's check the main winding, see if there's any fault to ground. And there is. Check the other winding. Yeah, so that's the issue. The main windings are shorted to ground. So the stator is definitely bad, unfortunately. Let's check to see if they're shorted to each other. So we'll do leg 1 to leg 2. And they are shorted together. Let's check it to the DPE winding. No connection. And of course the sense winding, I mean that's usually part of the main winding anyway. But let's just see if it's connected to the DPE. And it's not. We'll check the main windings. And it's connected to both. So yeah, unfortunately I would say the stator is bad unless I'm missing something. So let's cut this zip tie. We'll disconnect these just to completely be sure that we're isolated. And yeah, this might be a quick video. Okay, so now we're 100% isolated. Let's check this again to ground. Yeah, we still have a connection, so okay, no choice. We need to take the stator apart and just see how bad it is, but it's not good. They don't exactly make this easy. I mean, it should just be pulling those 4 long bolts that hold the stator on, getting the feet loose, and then sliding that out with a puller. But this exhaust is attached right here. And this, I thought initially was part of the heat shield, but it's not. It's part of the exhaust system. So the exhaust actually has to come off before we can get access to the stator. But I can't access the bolts because of this shield. This shield won't come out unless I remove part of the governor spring and some bolts and stuff up here. So they've made it a little more difficult than it should be. Just going to use the gear puller to get the bearing out of the end housing. It doesn't look half bad until you get to right there. So, yeah, unfortunately, this stator is bad. I think we knew that anyway, but now we can see it. So I'm going to pause it here. I'm going to take a look online and see what parts are still available for this generator. Well, parts are an issue for this machine. I did a Google search on this model number. Came up pretty much empty. Really, the only things that came up were carburetors and ignition coils and just kind of the miscellaneous Honda clone stuff that you would see, but none of it specific to this model generator. So, I then went to Generac's website. Generac acquired Powermate back in 2014 and typed in this model number, and it came back with no results. So I ran the search again, just taking off the last digit of this model number, and it did come back with a result, but it was not the right generator. So finding a suitable replacement for this just became a lot more challenging. But this is a very common Honda clone setup. It's on a lot of generators, from Homelight to Duramax, Champion, Predator, Ryobi, and Generac. And most of those vendors do not supply replacement parts, with the exception of Generac and Ryobi. So I checked their sites. Generac specifically, I looked for the GP5500. The power head is still available, but it's about $450, and that doesn't include shipping and tax. So that's pretty much not an option. This generator is not worth that much. I then went to the Ryobi site and looked at their 5500 watt generator, and to my shock, the stator they were selling for $135 plus $8 shipping and tax, which is a steal. I've never seen a stator that price before, so I went ahead and ordered it. And even if it doesn't work out here, it's a good deal. I'll use it on something, but I'm cautiously optimistic. Like I said, this is a very common setup. I think it'll fit, but I can tell you already, if it fits, it's going to be the outer diameter that fits on that bell housing. The stator on the Ryobi seems to be a bit longer, and if that's the case, then that's going to have a domino effect, meaning if it is in fact longer, the rotor that's on here isn't going to work out. We're going to need a longer rotor, which Ryobi does sell as well for $85. So again, not a bad price, but we would need a longer rotor bolt, longer stator bolts, and potentially a new end housing. I don't know if the Ryobi ball bearing is going to fit in this end housing. Won't know till we try. So I'm not afraid to try. I think, as Albert Einstein once said, if you haven't failed, it's because you haven't tried anything new. And at that price, I couldn't pass it up. So I did place the order. The stator's in this box. So I'm going to cut it out of the box. We will measure things up and see if there's any chance of making this work. Well, I may have hit the lottery on this one. The length of the Ryobi stator is about 5 1/8. And the length on this, it's a little bit harder to tell because some of the stator is under the lip here. But when I measure it up, we're at, I'd say about 5 to maybe 5 1/8. So we're within 1/8, I'd say, lengthwise, and that should be fine. Now, I still don't know if this is going to fit with the outer dimension as well as the inner, but I think that is a standard size. So let me try slipping this on and see how we make out. Yeah, it looks like it's a pretty good fit. The stator slid on without any resistance from the rotor, and as you can see, the clearance is really tight from the rotor to the stator, and that's the way it should be. So I think the inner diameter is fine. And as far as the bell housing itself goes, I mean, I think we're going to be okay. I can't actually get it to slide all the way in until I get the end housing on, and then I can use a dead blow hammer to just tap on the end, and hopefully that pops into place. To get the end housing off, it's pretty easy. There's two 7mm bolts that go all the way through the stator and held on with a nut in the back. Yeah, this one does come in at 5 inches, so it is 1/8 of an inch shorter. And it doesn't sound like much, but it could definitely be an issue. The rotor that's on that generator is expecting a stator this size. And if you put one on that's 1/8 of an inch longer, it's going to cause two issues that I can think of. First is that the end housing is going to be 1/8 of an inch further away from that ball bearing. So it's not going to hold it quite as well. With that said, it's only 1/8 of an inch. I don't think that's going to be an issue, but the bigger problem might be the alignment of the brushes. By having this 1/8 of an inch further out, the contact with the brushes will now be shifted by 1/8 of an inch. And I don't think we have 1/8 of an inch. This is a better look at what I'm talking about. The brushes were riding right there. So if we shift everything by 1/8 of an inch, we're right up on the edge here. And yeah, it might still work. I think we need to at least try, but I think this rotor is going to have to be replaced. Well, the good news is the stator went onto the bell housing, but as I feared, the ball bearing is falling short of where it should be. And it's actually closer to 1/4 of an inch instead of 1/8. And same thing on the brushes. I installed the brushes, tried to stick the camera in there so you could take a look. It's a bit blurry, but I think you can see the brushes are pretty much missing the slip rings by 1/4 of an inch. So I'm going to place an order. We'll get the Ryobi rotor and hopefully not run into any more complications. Okay, the rotor is on its way. It'll be here in a few days. The only thing I need to do at this point is just get the old rotor off. It's kind of hard to show you, the frame's in the way, but I'm gonna get the engine at bottom dead center on the compression stroke, fill that cylinder with rope, and then we'll be able to use that to lock the engine up and pop that stator off. The good news is we have threads. It's an M12 1.75. Doesn't seem to go in very far, so I'm just going to chase those threads with a tap, and then we'll find the right size rod and try pushing this off. So what I just did there was insert the rotor bolt and slide it in until it hits the crankshaft. At that point, I marked it where it exits the rotor, and then you want to use a rod cut slightly less than that length. And these are ones I've cut up previously for other projects. This one here I thought was the winner, but not so fast. This bolt is a pretty large diameter, and these rods look to be the same size. So if I just put this in and torque down the bolt to pop it off, this is actually going to push into the threads on the crankshaft. So I can't use this method. Instead, I'm going to use water, a little bit of Teflon, and some hydraulic pressure to hopefully pop that off. So I'm being a little lazy here, but the best way to do this is to get that engine off, stand it completely up. That way when you fill that rotor shaft with water, there's no air in it. And if there's any air in there, it's not gonna do what we're looking to do, which is push that rotor off. Instead, it's just gonna compress the air, and that's it. So I'm hoping at this angle, I can get enough water in there, and then when I go to tighten the bolt down, with any luck, whatever air is in there right at the end will come out before the bolt seals. That worked out pretty well. Now all we need is the new rotor. Well, something showed up in the mail today, and I think it is the new rotor. So I'm kind of excited, probably more nervous. I can think of a number of things that aren't going to work out. So let's get it out of the box and see if it's going to work. Okay, well, I had a lot of concerns ordering this part. They don't list any of the dimensions, and in fact, when looking at the parts diagram, they listed the ball bearing and the fan separately from the rotor. So I only ordered the rotor. I wasn't sure if I was going to get the whole thing, but I did. So that was the first concern, not an issue. The second one was the ball bearing itself. The outer diameter has to be the same in order to use the end housing that came with this generator. So I measured this one up. It comes out to about 47.1 millimeters, which is what we're at. And the new one, thankfully, if I can get this foam out of the way, comes in at the same number, 47.1. So we're good with the ball bearing. And then lastly, the actual rotor bolt itself for the Ryobi listed it as an 8 millimeter bolt in width. And the one that came off this machine was a 10 millimeter. So I was pretty convinced the Ryobi bolt wasn't going to work out. But now that it's here, I can see it's actually the right size diameter. And when you look at the length, it is a bit longer, which is exactly what we needed. So the bolt's going to work, this rotor's going to work, and we also have the new stator bolts to go with all that. So I'm going to clean this off, we'll get it on, get the stator on, and hopefully get this thing making power. Beautiful. I don't have a torque spec on this bolt. Usually I bring it up to about 23 foot-pounds, but this bolt is quite a bit wider than what I normally see. So I'm gonna bring it up to 25, probably closer to 30 in the end. Okay, that's 25. Let's go for 30. Yeah, that actually feels good. Could probably go a bit more. We'll bring it up to probably closer to 35. Yeah, 35 it is. Yeah, the new bolts are actually too long. We run out of thread before the bolt's tight, so I'm gonna have to stick with the originals, I think. All right, I got the rope out of the cylinder so the engine should spin. These bolts are now torqued down to 90 inch-pounds. I'm going to pull the engine over. Want to make sure there's no scraping down here. The rotor should spin freely. It should not hit anything. And we're good. Here's an up-close look at what that ball bearing is supposed to look like in the end housing. Also, I did put one of the feet on just loosely, and I was worried that the holes weren't going to line up on the frame due to the fact that the stator is just a tiny bit longer, but I don't think we need to do any modifications. I think that'll bolt up as is just fine. There are differences between this old stator and the new. The important parts are the same, which is the AVR hookup as well as the main winding out. But we do not have these extra coils. One of them's for the fuel solenoid, which isn't critical, and the other one is for the 12 volts that supply this like cigarette type plug that you'd find in a car. So that's not going to work. Not a big deal, but I think the bigger concern here is just what's going on with the main windings. The old stator had 4 wires coming out, and then they connected here and ran up to the outlets. The same 4 wires. We got red, 2 whites, and a black, which match down here. Now, the new stator only has 3 wires coming out. We got 1 black, 2, and then we got a white. So what they've done here is they've actually commoned up these white wires coming out of the stator. So we only have 1, which is fine. You don't need 4, but you do want to be careful when reconnecting this, because this is kind of where the limit of my AC knowledge comes to an end, and as far as what's safe and what's not. We only need 1 of these white wires. We don't need 2. And potentially we could just common these up and connect that to the 1 white wire. Now, you do want to be absolutely sure you know what wire is what. I've already tested this with the multimeter, and I'll show you that in a minute. But testing for continuity, you get a connection between these two. So you want to be absolutely sure that you know what wire goes to where on the receptacle before hooking it up to the stator. And same with the stator wires. You want to make sure you understand where the 240 is going to come out and where the neutral is. Because if you get this wrong, you could create a short in your stator, and your stator is going to last all of about 20 seconds. So what I don't know is by doubling these up to the white, they then go up to this panel right here. And then they get combined again in the panel somewhere. So, having 2 paths for the neutral, I don't know if that's a good idea or not. I could connect just 1, but then you have a live wire down here in the generator head. So ideally, I would just actually remove this wire altogether. So I'm going to get this panel pulled out. There's 4 bolts, 1 in each corner, and see if we can't pop this back off and see what's going on for wiring inside. Okay, got the multimeter set to ohms. I'm going to put one of the leads on the white wire and one of them on one of these black wires. We get 0.4 ohms. Check the other black wire. 0.4, that is good. And now between the black wires, we should get twice that. And we do. So that confirms the white wire is the neutral. And we have leg 1, leg 2. Now, this these are the wires going up to the outlets. And you want to be very sure of what these wires are. The color coding on some of these is pretty crazy and doesn't necessarily make sense. But what I'm expecting to see here is that two of these wires are basically a dead short. And you want to make sure you know which ones those are, because if you put those on a single coil, you're essentially just connecting the coil to itself, and the stator's going to melt down. So I'm pretty sure it's the white wires. We'll just set it to make an audible beep. And the white wires are basically the same. There is a direct connection. We can just check these others to make sure. The black wire, we got nothing. Red wire, nothing. We'll check the other white wire to the black and the red. So nothing. So these two are, in fact, connected together up in the control box. So I'm going to take that control panel off. We'll see if I can open it up. Ideally, I'd cut this out and just leave the one white wire. So we'd end up with 3 wires coming down from the panel that correspond with the 3 wires coming out of the stator. Yeah, there's a lot of wires in here, but the good news is it's pretty easy to fix this. These are the wires coming up that go down to the stator, and these are the 2 white wires in question. Now, this white wire goes over to the 120 outlet. There's a jumper wire right there that connects to the other 120, and then it's jumpered again over to the 240. And then this is the other wire here coming up from the stator, also being doubled up on the 240. So I'm going to leave most of this stuff alone, but this wire right here, that's the one I'm going to cut, remove it from the outlet, and just pull it out. Then we'll put this panel back together. I'll just double check that we have a good neutral connection to all the outlets, and we should be good to move on. All right, I've got one lead on the white wire, on the one that exits down by the stator. I'm just going to test all the neutrals, make sure we're still good. Yeah, and we're good. Okay, well, I was worried since the stator is longer that this wouldn't fit, but it looks like we have just enough clearance that I'm going to be able to get this onto the bracket. All right, it's the moment of truth here. Before committing and running this on gas, I'm just going to pull the the air box cover off, give it a little squirt of starting fluid, and hook up a light. I want to make sure that the wiring's good, that we see the light turn on for a second, and if that looks good, then I'll hook up the fuel and do a real test. Nice. .25 volts, 55, 56 hertz. So I'm going to bump the speed up a bit. Good. Okay, very nice. The engine speed was a bit slow, but that's because I took some of the tension off that governor spring when I reinstalled this cover. So bumped the engine speed up to 61.3 hertz. The voltage was on the high side of normal. It was 125 volts. I do want to bring that down just a bit, but when loading it up to 3000 watts, things did quite well. The voltage stayed steady and the hertz dropped to about 58.8. So overall, considering where we started, we're doing very well. And I was surprised actually that these LED lights were working on the panel. I thought potentially by emitting this 12-volt circuit that those wouldn't work, but they are working fine. It's still kind of a TBD on that hour meter. I thought it was advancing, but I'm not sure. So I do need to run it a bit longer and see if that meter has power. So let's get the AVR adjusted. We'll restart it. And I actually want to check the voltage here at the 240. Make sure that that's good as well. Usually it's counterclockwise to bring the voltage down, but not always. One full turn does about 2 volts. Sometimes it does 20. So in this case, we're at 125 volts. So I'm going to turn it 2 full turns counterclockwise. It should bring it down close to 120, maybe 121 volts. That's good. It's 121.3.5. Perfect. Okay, the voltages are good. Unfortunately, the hour counter does not look to be advancing, so we did lose that with the 12 volts. Potentially, I could get something in there to correct that, but for now, I think this is a win. I'm going to resecure the AVR, we'll get this back inside and finish it up. Well, that just about does it. I think the exception is the end cap on the power head, and I'm going to leave that off for right now. When editing this video together, I noticed when this started for the very first time with this power head, I heard what sounded like arcing, and I haven't heard it since. But I do want to do some more tests on it. I want to make sure that the brushes here aren't arcing. If they are, it's going to lead to overheating and failure. What happens is this plastic here that holds the brushes will literally just melt, and then you lose power. So I want to make sure that this is solid before selling it to someone. And as far as the rest of it goes, I was kind of bummed that this hour counter doesn't work. There are other options for this that do run off of AC. So, I took a quick look on Amazon. There was a few for around $13 that may or may not fit. And I also looked at some power adapters that potentially could just be tapped into the 120 side to create 12 volts to power this as well. But, you know, in the end, I've probably invested close to $240 in this generator, and it's well worth it. I mean, this thing is practically new. It only has 60 hours on the engine, but this generator used probably isn't going to sell for much more than 400. I'd say 450 on, you know, the day after a storm. And yeah, I've got to cut off the money spent at some point. So the hour meter honestly is not that important, and neither is the 12 volt outlet. So I think I'm going to call it right here, guys. So I hope this video helps someone. Thanks for watching. Actually, not quite done yet. I think it was the handles rattling at startup. Let me show you. They're both loose. That one's a lot worse. So I'm just going to tighten those up. We'll start it up one last time and make sure everything's good. Okay, well, I didn't see or hear anything unusual this time, so I think we're good. I'm just going to get that end cap on, and then I'll call it done. And now I'm done. So, hope this video helped someone. Thanks for watching.